You know, we hear all the time about these massive AI models living in the cloud. But what about the AI you can't see? It turns out there's a quiet revolution happening on a much, much smaller scale. It's called tiny machine learning, or TinyML. And this invisible intelligence, well, it's already changing just about everything. To really get what this is all about, let's start with a fascinating puzzle. So, imagine you're a wildlife researcher, and your job is to protect a herd of elephants. Sure, you can track their location, but how do you really know if one is okay? Is it calm, is it stressed out, or is it showing the very first signs of being sick? You can't just ask it, right? Well, researchers trying to protect these incredible animals ran into this exact problem. They realized pretty quickly that a simple GPS dot on a map just wasn't going to cut it. To actually help, they needed to know how the elephant was doing, not just where it was. They had to get a whole lot smarter. They had to understand the animal's behavior, its well-being, and they needed to know it in real time. This meant going way beyond simple location tracking. We're talking about a huge leap into complex health monitoring, especially when you're out in the middle of the wild. And here is the solution they came up with. And it's absolutely brilliant. A smart collar. It's got sensors for things like movement and temperature. But here's the magic part. It had a tiny little computer on board. This thing wasn't just collecting data and sending it off somewhere. No, it was analyzing it right there on the elephant's neck. And this is our first real look at the power of TinyML. So that elephant collar, it perfectly tees up the core idea of what TinyML is. And trust me, there's an amazing analogy that makes it all click into place. Okay, so here's the textbook definition. TinyML is basically a field of AI that's all about running machine learning models on incredibly small, super power-efficient hardware. Think the little microcontrollers you'd find in your smartwatch or, a smart toaster. But honestly, forget the textbook. This slide, this is all you need to know. The best way to think about TinyML is like an ant that has the strength of an elephant. It's about packing an unbelievable amount of intelligence and computational power into the absolute smallest package possible. So what gives this tiny ant all that power? Well, it really comes down to four things. First, all the learning happens right on the device itself. Second, it uses almost no power. We're talking milliwatts, just sipping energy. Third, it can fit into tiny memory spaces, like just kilobytes. And because of all that, it's super cheap to put into millions or even billions of devices. So all these features add up to this really powerful idea of processing data at the edge. And all that means is doing the computing right where the data is being collected instead of shipping it off to some distant server in the cloud. And this breakdown shows you exactly why that matters. Traditional cloud AI, right? It sends your data away. That can be slow, you need an internet connection, and it raises all sorts of privacy flags. But Edge AI, what TinyML does, flips the script. It processes data locally, so you get instant results. It works offline, and maybe most importantly, it keeps your private data private. And this is a benefit I think we can all get behind. Whether it's a voice command you give your smart speaker or health data from your fitness tracker, TinyML means that sensitive information never has to leave the device. That's a massive win for privacy. And let's go back to that elephant collar for a second. There's no reliable Wi-Fi out in the savannah, right? The fact that TinyML works offline is what makes it so tough and reliable for jobs in factories, on farms, or in any remote place where you just can't count on a connection. So the big question is, how on earth do engineers actually pull this off? How do you take an AI model that usually needs a giant server and squeeze it onto a chip the size of your fingernail? It's a really tough problem. I mean, they're working against some serious limitations. These tiny chips have very little horsepower and almost no memory. They have to run on a tiny battery for months, sometimes years. And they often need to give you an answer, like, right now. But of course, engineers have come up with some incredibly clever tricks. First, they use something called model compression to shrink a big AI model down. It's kind of like zipping a huge file. Then they use efficient inference to simplify all the math so it can run super fast. And on top of that, they use special hardware and software tools that are built from the ground up to make this tiny AI fly. Okay, now for the really fun part. Let's look at how this small tech is already having a massive impact in places you would never, ever expect. Take farming. You can have tiny sensors buried in the soil, analyzing moisture levels to make sure not a single drop of water is wasted. Or drones with tiny ML cameras that can fly over a field and spot crop disease with amazing accuracy, potentially saving an entire harvest. And that fitness tracker on your wrist? It's doing way more than just counting steps. It's using tiny ML to analyze your heart rhythms in real time, looking for irregularities. This kind of nonstop, personalized monitoring is already helping to keep people out of the hospital. In a factory, you can put a tiny sensor on a machine that just listens to the vibrations, and based on those sounds, it can actually predict a failure weeks before it happens. This kind of predictive maintenance is a total game changer, cutting costs and preventing huge delays. And get this one, this is just incredible. In our own homes, a smart baby monitor can use tiny ML to actually analyze the sound of a baby's cry and tell the parents why the baby is crying. Is it hunger? Discomfort? Pain? It's not just hearing a noise, it's understanding what it means. So, as you can see, this technology isn't just some niche idea. It's weaving itself into the very fabric of our world. The future of tiny ML is quite literally going to be everywhere. And if you look at the numbers, they tell the same story. The market is projected to be worth over $10 billion by 2030. That is absolutely explosive growth, and it points to a massive shift towards putting intelligence into everything. So, what's next on the horizon? Well, get ready to see it in a lot more of our cars and electronics. It's going to get even more powerful as it connects with 5G and the Internet of Things. And as the tools get easier to use, this power is going to get into the hands of more and more creators and innovators all over the world. And that really brings us to a final, fascinating question. As this incredibly powerful AI gets smaller and smaller and just sort of disappears into the background of our lives, it makes you wonder, what new problems could it solve? I'll leave you with this. Where do you want to see this invisible intelligence show up next?